So I need to tell you about something that happened basically in the last week. I cloned this repo, I ran this command, and then I went to sleep. And when I woke up in the morning, my code was much better. Not like, oh, someone pushed a fix. Not like, oh, the CI/CD pipeline cleaned things up. An AI agent spent basically the entire night running experiments on my code, trying new things, testing them, keeping things that worked, throwing away what didn't work, over and over and over and over again, hundreds of times, while I was pretty much unconscious. And I woke up to basically this list of everything it had tried, what it threw away, what it kept. And this is not like hypothetical. This isn't just like some demo. This actually happened. And it was because of this, basically this 3-file repo that Andrej Karpathy put together, which came out in March. So it's been a little bit of time, but I thought this is like so interesting. So wanted to talk about it more. It's called AutoResearch. I think it has like 50,000 GitHub stars in the time that it's been made available. And honestly, I think most people who have started this are probably just missing what it actually is. I think most people think that it's like this ML project that will just like automatically try and improve an ML pipeline, a training script, some sort of toy. And it's really not. It's like this design pattern for making anything that you can measure better automatically overnight. And I'm going to show you how it works. And then I'm going to go set it up live. So hopefully if you follow along, you can do this tonight. And yeah, let's get started. So before I show you the repo, I need to maybe to start to talk about why this matters. Andrej Karpathy, if you don't know this person's name, he built the training infrastructure at OpenAI. I believe he's the reason why GPT works the way it works. He left, came back, and in 2025, he coined the term vibe coding. The idea is that you just put your idea in it, you describe your idea, and the AI writes it. But in 2026, he went a little further. He started to talk about what he calls agentic engineering. And then he said something that I've haven't really been able to stop thinking about. He said, you're not typing any code anymore. You're now just spinning up AI agents. And for those that are following along, like a lot of this has changed in a very short period of time, probably since the December change which Anthropic made by giving away a bunch of tokens for Claude Code, where people really used that time when they were away on their break to like really spend more time with these agents. Karpathy though shipped this AutoResearch project, and it is so good. And this is what sort of hooked me to this repo. It's almost stupidly simple. When I first opened it, I literally thought that something was missing. This was more like a Ralph loop, because it's essentially 3 files, the 3 files and a markdown document essentially, and that's it. That's the whole project. That's the design, and it's took me, frankly, just an embarrassingly long time to understand why. Let's jump into the repo itself and look into it. So I'm going to jump over to my computer and walk through the repo. All right. All right. So this is the repo that I was talking about that has the repo. You can see here that it has like one file that's called prepare. So if I move some stuff around on my machine, I should be able to now find this thing called prepare. Wow, I got a lot. Of stuff here. Okay. So prepare here is basically the oops, so you can see it. It has basically this like preparation. So like this is on a AutoResearch experiment that does some work here. So like what this does is it like downloads some training data. I think it like trains the tokenizer. Oh, it trains a tokenizer, builds a data loader. Here's this tokenizer training. And then it should have this like evaluation function. Make a data. Yeah, here we go. Evaluate. This sums the byte tokens and then produces some result here. And this file is like, as I understand it, is like sort of sacred. You don't touch this prepare function. It just like this prepare Python file. It just like prepares the data, produces some score, and that's basically it. So the second file that is in here that's kind of interesting is called train. And this is essentially just like, if I see the GPT config class, it should have causal self-attention. And this is sort of the full GPT model, the optimizer, the training loop, blocks. This is GPT here, where we have the transformer, and I've done some of this before with rotary embeddings, and we like went into like a bunch of detail. It's probably this time last year when I spent some more time on this. Probably been a while since I've done this. And then here this should be the N layer. Yeah. Make sure you can see it. Yeah. The N layer, the head, the embedding, and the vocab size. And the agent can like change any of these things in this file. So this file is like fair game to change. It can rewrite the attention mechanism, swap some activations, change the optimizer, restructure the model. Basically everything is you can change in this file. And then one of the more interesting parts, I mean, if there's just like one file here, this program, and this is like so well written, is this, which is the program file. So what this does is essentially sets up the new experiment and has like, here's what you should do, set this up. Each experiment runs on a single GPU. The training script runs for a fixed time period. You launch it with UV run train. You can modify the train. You can't modify prepare, like I mentioned. And the goal was to like optimize that val BQB or BPB value to get the best performance. And then VRAM is this like soft constraint. Some increase in acceptable is acceptable, but it shouldn't blow up dramatically. And then it asks for this like output format. And where is it? It says like 0.01 in here. Yeah. There's some criteria here that's put in like what you can't do. Like you can't add a zero. You can't like, if you're going to add hacky code, don't do it. If there's a 0.001 improvement from deleting code, definitely do that. And an improvement of 0, but much simpler code, keep. Run the first run to produce some output, and then log the results, go through the experiment loop, and this is where it's like super interesting. So this is where it's like loop forever. Look at the get state, the current branch, the commit. We're on tune train.py with an experimental idea by directly hacking the code. Git commit, run the experiment. If the grep output to read, if you can't get that, record the results. Basically just like go in a loop. And this is kind of interesting. So it says never stop. Once the experiment loop has begun, do not pause. Do not ask. You're autonomous. If you run out of this, think harder. It is wild. Yeah. As an example, like here's what you should go through. This is like so interesting. So Here's the thing that I think people miss about this design, and it's the one most people skip. Every experiment runs for exactly 5 minutes. Not until the loss converges, not until it looks good. 5 minutes, wall clock, fixed, done. And I'll be honest, when I first saw this, I thought it was sort of like lazy. Like, why not let it go longer? And then I realized that the cap is actually genius. And if you think about it, the agent's going to try like hundreds of different things. Different model sizes, different batch sizes, different architectures. But at 5 minutes, everything is sort of comparable. Experiment A gets 95% of the 5 minutes. Experiment B gets 97. A is better. Next. And you sort of can move on. And the math gets scary fast. 5 minutes per experiment, 12 experiments per hour, 8 hours of sleep. That's hundreds of experiments that can take place basically overnight. So by the morning, I think when Karpathy ran this, it had like 700 experiments in sort of like 2 days. And the agent discovered like 20 pretty real optimizations, things like reordering, QK norm, rope, and an actual architectural insight. And this kind of thing, a human researcher might spend like weeks trying to converge on through intuition, maybe a lot of coffee, and staring at these loss curves in weights and biases. And the agent just sort of like tried it because it tries everything. It doesn't have intuition, it has patience, basically like infinite patience. And the loop section of the program, where is loop in here? And here's the actual loop, the mechanism. Karpathy calls it, I think he calls it like a ratchet. Step 1, modify the train.py with an idea. Step 2, get commit. Step 3, train for 5 minutes. Step 4, check the value of BPB. Step 5, if it's improved, keep the commit, advance the branch. If it didn't get it, get reset, revert, try again. And it's like a ratchet. It can only move forward. Every kept commit is sort of like a measurable improvement. Every discard is a data point, and the get history sort of emphasizes is in the research paper. You can literally get log the branch and see every experiment, every hypothesis, every result. Now at this point in the story, I thought I understood AutoResearch. I thought it was like pretty good for this like topic around ML research. Has a clear design. It's a pretty nice repo. Karpathy does some great videos. But I was wrong. I think I was thinking about this in a too narrow way. Because then I saw what Toby Lutke, the CEO of Shopify, did. And Toby basically spent some time, I'm not entirely sure, but looked at like a templating engine. Not ML, not model training, not neural networks. Their templating engine. Let me find the tweet. I think it's this. Do I have it right here? Yeah, here we go. So this is this tweet, which says, okay, I ran AutoResearch on this template and it's 53% better. They wrote about it, about the improvement, and it's like 61%. It's just crazy to think about. Okay, so they also, I think they did 93 automated commits or something like that. Is it in here? Have the commits? Yeah, here we go. So it's like, here's all the stuff it did. And this is wild in my opinion, that like 53% improvement is just crazy overnight with no like human in the loop. So, and that's the moment basically when I started to think about this, the understanding of this like completely broke and reformed basically my opinion of it. Because like AutoResearch is not this like ML project, and maybe it never was. It's sort of this pattern. And you need sort of three things: a file the agent can edit, a metric it can measure, and a fixed time budget, so experiments are sort of comparable. And that's it. This could be things like your API response time, that's a metric. Your Webpack bundle size, that's a metric. Database latency, that's a metric. A Lighthouse score, your test suite, your compile time, the time it takes to run tests. Anything with a number that you basically want to lower and code you can change is a candidate basically in this loop. And once you see that, it's really hard to unsee it. And I start to think about problems and think, could an agent optimize this overnight? And the answer is almost always yes. All right, I've talked about this enough. So let's actually go and jump into a project and do this directly. So I am going to find somewhere for me to put this. And we'll pull up our timer again. Okay. Let me find somewhere to put this. Z. Okay, so I have this on hats now. Let's just bring this up on another screen. Okay, so we have this here. Let's go ahead and we'll go install UV here. Okay, then we're going to go get this Carpathy project. We're going to go into AutoResearch. We should be able to see all these files. Let's make sure that we have everything. This machine is not a... I picked the wrong machine. Okay, one sec. Let's go get a... let's go to our friends at RunPod and go get a GPU to use. Sign in. I can't remember if I think I used GitHub. Okay, I want a new GPU. Let's see. I don't want a deployment. I actually just want the raw. These are for serverless now. Interesting. How do I find pods? Okay. Let's go get one that seems reasonable. GPT-1, so it should be pretty small. So I think we can probably go for like a smaller. Well, there's any A100s available. I don't know if oh yeah, let's take this one. 149. How much are these? 32 gigs of RAM, 80 gigs of VRAM. I don't think we're going to be more than an hour, so let's just go get one of these. Do I need a network volume? Yeah, that's fine. Okay, I think this is probably enough. Let's hope for the best. Okay, so I'm going to deploy this. We should get a container that we can use slightly in a second, and then I can download and we can rip. Basically, I installed this and just I realized that the machine that I'm using right here is a Hetzner machine that does not have access to a GPU, because I don't have the kind of money just to run a GPU continuously like this. Nor does probably anyone right now. All right, looks like we got a machine here. Let's go log in with it. Yeah. All right, try again. Let's get this repo. Clone it. CD AutoResearch. And then I think we need to get UV because this machine certainly will not have UV on it. Let's just source this. Okay. Run UV sync. Now we actually have things we need. All right. Just going to go ahead and like set up and sync the packages that we have in this repo. This must be a bug. All right, okay, so we got that. Now it looks like this is installed, so we can run prepare. And this is going to produce basically, this installs the Python. So this is going to, this has installed the Python packages. Now we're basically running prepare, which does like a data prep, downloads the training data, trains the tokenizer, writes the cache, and it'll take, I think, about like 2 minutes just for us to get a baseline. And while it does that, okay, it's done. It's ready to train. Okay, so let's run a baseline. So just going to run UV run train. Sending unauthorized requests, unauthenticated requests. Okay. And then we should get a number here. I think it's going to be like 0.99 something, maybe not. Wonderful. Who doesn't like CUDA errors? Every time I try to do a video, I get errors. How? Oh, this sucks. I feel like I'm just so unlucky when I try and do these things. Like, I'm just copying a repo. Like, give me a break. Okay, actually, I probably need to just pipe this in something that I can see it. And maybe these are just like not important. Actually, maybe it will figure out how to fix it. Is the other question. Let's actually figure that out. I think that's like much more fun. Okay, so I'm going to check out a new branch here. I'm going to install Claude Code. Does Claude Code. Okay, let's go ahead and install it. Where are you? This is going to install Claude Code. Okay, then we need Claude. Let's keep it in dark mode. I am going to use my account. And it's not going to work, so I'm going to have to copy this. Looks like we're good. All right, so now we have on this right side, let's get rid of this one and we should be good. I am gonna keep it on medium and then we should be able to basically just say read the experiment loop and go read per program, kick off the experiment loop. If train.py does not run, fix it. Okay. Then I'm going to open up a new terminal. Say, do you want to read? Yes. Maybe I needed to like set the permissions. Correctly. Sorry. All right, now I'm going to watch the results basically. Hopefully it's going to fix the error to run the baseline. Actually, I don't even know if you can see this. if there's actually a bug on the repo for it. Let's check. I'm not entirely sure how Triton works, but my guess is that that is the problem here. It's just like every time I try and touch anything with a GPU, there's a PyTorch error, there's a CUDA error, there's a CUDA error. It happens like almost every time. Okay, it turns out I was an idiot and did not install Python here apparently. So I needed the dev version, which is why this didn't work. And then it should run the experiment. We will get there in this video. All right, with that, let me change the time. So let's keep it like, let's try and keep this into another 15 minutes. Let's see if we can do that, and hopefully we can get like a couple of experiments to show on the right hand side, and we can see how we go. Now it's going to clear the Triton cache and run it again. It is a crazy world that we live in when you can do this. It'll just like fix itself and now it's going to train, which is just absolutely nuts, to say the least. Will it do this before it finishes? And will it keep it in context? Is the other question. Okay, so it's going to run the baseline here again. I guess it's been 5 minutes. I'm giving it a hard time. This is why, like, you have like, I think that there's like this post about like there's two separate types of people. There's people that are using the audio model on GPT, on their chat GPT, and they're like, look, it can't even figure out anything. And then there's other people that are like spending $200 a month and getting like $5,000 of value out of these tools. And this is a good example, right? I could leave this run. I don't know how much value I'm going to get from this, but like it can run for a long time, and then I might hit the quota and then I'll be cut. And then I have a series of backups that I could use. I could use a cheaper model if I wanted to here as well. I could use one of the Kimi models. I could run a model locally like we did last week with Gemma 3 and have Gemma 3 like continue to improve itself. So like Gemma 3 as a model has its runs on a machine. Then I could have Gemma basically like try and improve itself at the same time. All right, this is taking a while. Let's check the log. Was it called run.log? Oh, wait, this is cooked. Let's see. Okay, so it's running through a loop right now. It's at 68%, 70%. Takes a while to run, actually. And then hopefully it's going to give us a score at the end. Watch 10 in 10 cat. $90. Losses at 4. What was it meant to be at? Hopefully we get a baseline and we can start to run this thing. Almost there. Takes 5 minutes to run the experiment. Okay, so the baseline was 1.1.112 here. Now it's going to probably go away and like try and improve it, hopefully. Figured out an email of AutoResearch@example.com. Okay, so now I can go back here. If we watch this example, it's now going to like try and do something else. So you can see here, it's like, okay, I'm going to try and increase the depth from 8 to 12. This is what the like magic of this entire thing is. So now it's like going to go try and train it again. So this is going to take another 5 minutes to go run, and we'll do it one. Well, I'll do it one time. It's going to go train, and then it should show whether that made a difference here. And then it'll, in this status, it'll say whether it dropped it or kept it. And it is like absolutely crazy how good it is. While it does this, let's try and show you something else. Yes. Okay, so it crashed. So, because it was out of memory. Maybe it's not clearing its memory after each run. Let's hope not. And let me show you an example. So let me show you this thing. Okay, so this is like a project I have that I think we'd shown before, which has like the website to help do some video editing. And you can see here that I have like this AutoResearch in here. So I did something similar in a repo, and it has like, here's a bunch of stuff to do. And then it will keep track on like what it did and what it did not do in here. And then I have this JSON L file. So you can do, let's see, cat AutoResearch.jsonl. This has like all the things that it did. So it's like similar to what we were looking at in this tab, where it is essentially like trying to do something. So this is like making changes in the code base, and it's trying to optimize in this, the metric I think was like somewhat like latency, like the overall size of the bundle, the cache size, how long it took for the waveform to show, and a bunch of other stuff. So just how to like kind of optimize this use case. But you can see how it's just like, it's just like a very different way to prompt the models, is to say like optimize towards this goal rather than optimize the, where am I going? Like fix this bug with this thing, build this thing. Like these things are like where I can see like research just like being in a very different state when it can run so many of these different experiments over and over and over and over and over again in a loop to try and find one that works. Like you'll see here, like in this example, like, okay, it's gonna like, it's trying to train again. I think it's gonna take 5 minutes for this to train, and we'll see if that like experiment worked. And you can imagine if you just left this overnight, it could do hundreds of these different experiments. And the human capacity to be able to do this is like, would take me so long to be like, edit the file from 96 to 64. Okay, let's change the batch size to 32, and then hit run. And like that would just be like so inefficient. So this is like a great way, I think, of just optimizing towards these numbers, both like the website that I just showed here for some of the work that we did to optimize a website, and then like it obviously applies to research, but like you can extend it, which I think is like kind of interesting. All right, let's see how we're doing. 14, we might need a little bit more time. Let's give us 5 more minutes and see where we land on this. It's like Please finish soon so that I can show this. I could have done it around this earlier, but in the spirit of trying to do these things as live as I can. When did this start? I guess it's been running for 5 minutes. How long was the other one? Oh, I guess I could just like cat the log and see. I guess it's at 84. Can you see this? Let me make sure you can see it. My face isn't covering it. Okay. Probably close to these. Kind of hoping it just shows up here with the result. Let's see. It's going to get the result and post it. Okay, it was a worse baseline. And it should update here. I guess it should update the results. There you go. Okay, so you can see this like moved this value to 1, the other one crashed, and it's going to commit that. It's going to basically like it's going to like ignore the change, go back to what it was before, and then it'll try something else now. So it's going to like think about the file and then like figure out how to improve it. So it's doing something with the something. It's like going through this right now, and it'll come up with probably another idea. Go once. So it just discarded this, and it has like the description of what it is up here. I'm just going to wait for it to come up with another idea, and then we'll maybe call it. Wow, it's got a timeout of a minute. I mean, all it's doing is just adding this. Like, what could it possibly be doing? Very odd. I wonder what it is doing in here. Because it doesn't need to run for 10 minutes. Anyway, all right, let's jump back to my other... AutoResearch. All right. So let's talk about what this actually means. Because I think the implications might be bigger than people realize. First, like, everyone's job is changing. not necessarily disappearing, but changing. I think that the human role in this loop isn't necessarily writing that train.py file anymore. It's like writing this program.md file. It's choosing sort of the right metric, defining the search space, setting the right constraints. And that's really like, in this case, I think more just like research direction, more like taste, judgment. And honestly, that's like really hard, like knowing the things that it could tune or change. And that's the part that requires, I think, this is like this expertise and wisdom. And the thing we don't have a good word for, that's somewhere between sort of like intuition and expertise. The agent writes the code, you write the brief. Second, I think what I think we're seeing is like this overnight economy where you ship code during the day, you point your agents at it overnight, and then on Monday morning or whatever it is, the agent found like these like 14 vulnerabilities, 14 optimizations over the weekend. And I think that's not necessarily like science fiction. That's basically what the CEO of Shopify basically did. And he did it in production code using this agent called Pi, which we'll hope maybe get some time to do a video on or a stream on soon. And third, maybe the more uncomfortable one, Karpathy is the person that built the GPT training infrastructure, and saying that his own skills are basically changing. He sort of says that agents have like crossed this threshold, which I mentioned earlier, like when people had the break and they were playing with Opus, I think over the break, and now he like barely writes any code himself. He writes this program.md file, directs it, designs it, and doesn't really implement anything. And if that's true for like this person, what does that mean for basically everyone else? And I think that means we're all becoming these like research directors where, whether we know it or not, the question isn't, can you write code anymore? The question is like, can you frame the problem? Can you look at a system, identify the metric that matters the most, define what's allowed to change in the system, and write basically like this brief, clear enough that an AI can run hundreds of experiments on it overnight. I think there's two parts to this. There's like the code itself, and then there's design, which is a totally, I think something else to maybe think about here as a critique to this. But the new skill feels more like new literacy, like how to work with this thing. So let me bring this back to sort of where I started. I went to sleep, I woke up, my code was better, and now you know how 3 files, 1 metric, and this Ratchet only moves things forward. And an agent with sort of infinite patience can make a big difference. If you haven't looked at this, it's so much fun to try it. You can check out the repo. There's forks, I think, for everything. And then the fun part is when you wake up in the morning and you're like, what happened? What did my agent do? And you ask yourself a question. What else in my code base, in my side projects, in all of these different things, is a number that I want to change or move? And can I put this thing to work? All right, thank you. And if you have suggestions for anything else, I appreciate it. Bye.